Okay, so for this part, this cannot be done with process of elimination as we've done the previous part. It is best case and worst case runtimes for each of these algorithms. So let's go ahead and look at insertion sort. Okay, so insertion sort best case and worst case is going to be dependent on how many inversions we have, right? And so the best case is when we're actually passed in an entirely sorted array, right? So if I pass in like 1, 2, 3, 4, this is my array that I pass in. Do I need to do any inversions? No, right? And so really all the work that I'm doing is simply looking at all of these elements. And that's going to take a total of n times, where n is the length of the list being passed in. So my best case is going to be n. Okay. And now what about my worst case? My worst case is going to be when I am passed in the exact opposite of a sorted array, right? And so that's going to be when I'm passed in an inverted array. So if I pass in 4, 3, 2, 1, I don't have to do any work for 4 other than just look at it. But when I get to 3, I need to do one inversion, right? So I need to first look at 4, and then I need to look at 3, plus do one swap. And so that's going to be a total of 2 steps for 3. And then for 2, I still need to look at it. That's 1 step. I need to invert it with, let me actually draw the resulting element, the resulting array. So I have 3, 4, 2, 1 after this, right? And that's going to be, for 2, it's going to be inverting with the 4. And then once it's here, I need to invert it with the 3 again, right? So that's going to be a total of 3 steps for 2. And what about for 1? So now my resulting array is 2, 3, 4, 1. Well, I know that 1 as a human, not a computer, is going to go to the very beginning of the list, right? And the reason I know that is because I need to invert it a total of 3 times with 3 of the previous elements to the left of it. Plus, I need to look at 1. So that's a total of 4 steps that I'm doing for 1. And you can see how this can be generalized to large n, right? So if I have total of n elements, this is going to bring me to plus n, which is really just equal to quadratic. So theta of n squared.